Alright guys, welcome back. So for the first few months, it felt like open source was losing the war. While models like GPT-5 and Gemini 3.0 were sprinting ahead, open models were struggling to keep up. But DeepSeek just dropped V3.2, and honestly, this is a counterattack we've been waiting for. We're talking about a model that doesn't just chase benchmarks, it's actually introducing 3 major technical breakthroughs to fix efficiency and reasoning. In the high compute version, Special A just took home gold medals at the International Math and Informatics Olympiads. Let's break down exactly how they did it. To understand this paper, you only need to understand these 3 pillars. First, they fixed the architecture with something called DeepSeek Sparse Attention, or DSA, which solves the long context cost problem. Second, they completely overhauled how they do reinforcement learning, dedicating way more compute to post-training than anyone in open source has before. And third, they stopped relying on human data for agents and built a massive synthetic data pipeline, which they shared with us in the technical report. This isn't just a fine-tune, this is a full system upgrade for DeepSeek. Let's start with the architecture. We all know the transformer bottleneck. Standard attention is quadratic. If you double the context length, the cost doesn't double, it quadruples. That kills you at 128k tokens. DeepSeek's answer is DSA. They managed to drop the complexity from OL squared down to OLK, where k is just a small number of selected tokens. They did this without degrading performance, which verified on benchmarks such as Fiction.live. Basically, they made long context dirt cheap without making the model dumber. Here's the engineering wizardry behind that. They use a component called the lightning indexer. Instead of every token paying attention to every other token, the indexer quickly scans previous tokens using a lightweight calculation. Equation 1 in the paper, and selects only the top k most relevant ones for the heavy lifting. They run this indexer in FP8 precision to keep it blazing fast. It's like having a highly efficient secretary filtering your emails so you only read the important ones. Now, you can't just initialize a sparse model from scratch, it usually fails. Their recipe is clever. They start with a dense warm-up stage where the main attention is standard, but they train the indexer to predict what the attention would look like. That's the KL divergence loss you see here. Once the indexer learns the pattern, they switch to sparse training for the remaining 95% of the run. This prevents that catastrophic drop in performance you usually get when you try to sparsify a model. So, does this actually save money? Absolutely. Look at the pre-filling costs on H800 clusters. The previous version cost about $2.40 per million tokens at long context. V3.2 drops that to only 40 cents. That is a 6x reduction. If you are building RAG applications or anything requiring massive document processing, this architectural change alone is basically money in your pocket. Most open source models spend almost all their compute on pre-training and barely any on reinforcement learning. DeepSeek flipped the script. They allocated over 10% of the total compute budget just for post-training RL. They used their signature algorithm, GRPO, Group Relative Policy Optimization. Instead of training separate models for math, code, and chat, they merged everything into one mixed reinforcement learning stage to prevent the model from forgetting one skill while learning another. Here's the thing. Scaling RL is a nightmare. It's super unstable. The technical report details 3 specific fixes they needed to make this work. First, they fixed the KL estimator to be unbiased so gradients don't explode. Second, they implemented off-policy masking, which basically ignores data where the model drifts too far away from the reference policy. And third, the mixture of experts routing. They forced the training to use the same expert paths as inference. Without these engineering hacks, the model would have collapsed during training and would have been hard to balance across load when trying to distribute it. And then there's this beast. DeepSeek V3.2 Special A. Special A. Who knows? This is their let's see how far we can push it model. They trained it exclusively on reasoning data, and crucially, they removed the length penalty. They let the model think as long as it needed. The result? It outperforms GPT-5 High and Gemini 3.0 Pro on math benchmarks, hitting 96% on AIME and achieving gold medal status at the International Olympiad in Informatics. It proves that if you let open models think long enough, they can match the absolute best proprietary models, who also use similar tactics in some of their benchmarks that they present out to the public. They also fixed a major inefficiency in how reasoning models use tools. Usually, when a model calls a tool, the previous thinking steps get deleted to save context, forcing the model to rethink the problem from scratch. DeepSeek V3.2 keeps the reasoning history alive across tool calls. It only resets when the user sends a new message. This context persistence bumped their score on Terminal Bench from 39% to over 46%, and shows how small changes like this can impact benchmark scores a lot, which shows how brittle today's models are as well. Pillar 3 in DeepSeek's insane pipeline is data. They ran out of high-quality human agent data, and so has every other frontier lab, so they built a factory. They automated agents to mine GitHub issues, create search tasks, and generate reasoning problems. They synthesized over 85,000 complex tasks across 1,800 different environments. The key here is that they built automated verification functions, code that checks if the AI is right, so they could run RL at a massive scale without needing humans to grade the answers. Here's a concrete example of that synthetic data. A trip planning task. It looks simple, but it's a combinatorial nightmare. Budget constraints, location rules, rating requirements. It's hard to solve, but remarkably easy to verify with a script. This hard to solve, easy to verify dynamic is exactly what you need for reinforcement learning to work its magic. Let's look at the scoreboard. On pure reasoning, math and code, Special A is actually beating Gemini 3.0 Pro on benchmarks like AMIE and HMMT. Even the standard V3.2 model is trading blows with GPT-5 High. The token efficiency is decent, though the Special A model does burn through more tokens to get those higher scores. Do you want it right? Agent capabilities. In the real world, this translates to serious agentic capability. On SWE Verified, which tests real software engineering skills, they hit 73.1%. That is closing the gap significantly with the closed source leaders who are sitting around 76%. And remember, DeepSeek didn't train on these specific benchmarks. This is generalization from the synthetic data factory I mentioned earlier. Now, let's keep it real. It's not perfect. The paper admits that because they use fewer total training flops than Google or OpenAI, the model's general world knowledge is still a bit behind. Also, the reasoning models are verbose. They output a lot of tokens, which increases latency. But considering the efficiency of the architecture, it's a massive step forward. So the takeaway? DeepSeek-V3.2 proves that open source isn't just copying anymore. They are innovating on architecture and training methodology. DSA solves the context cost, and their RL pipeline proves we can synthesize our way to smarter agents. I've linked